All right, I think we are off to the races here. Once again, after fiddling with the AV setup in this room for a couple of minutes, but less than before, I think. How's everybody doing? Hanging in there? We still, let's see, was everybody who's here now also here last week? Or okay. Yeah. Did you guys happen to watch any of the stuff from last week, or are you just playing catch up?
Catch up.
That's cool. I just wanted to check and see, like, so if if stuff doesn't make sense to you, sort of the canonical way to get back to that is just to look at the screen recording from last week. But we can like slow things down today and kind of like go over stuff again, especially if it's not making sense to people as we go along. Cool. So just to recap what we did last week, if you weren't here, is we started. You can see that we're writing very simple little scripts here. This is just 16 lines of code, but it's enough to do some stuff. So we can put some images up on the screen. We can create a window, put an image up on the screen, move it around like so, and wait for the user to press a key at the end to make the task go away. So that's pretty good for 16 lines of code. And actually, that's really only like 12 lines of code, right? Because 4 of those are blank lines just for like visual separation. So not too shabby, really, right? And we could condense this down further if we really wanted to, but I think that's nice and readable as it is. So I think what we're going to try to get through today is we're going to do just a little bit more with like moving stuff around the screen, and then start thinking about what we might want to do to turn this from a simple dumb little smiley face to something resembling like an IAT cognitive task. And we're not going to get all the way there today, but I think we'll get further than you might expect. So this, if you were here last week, is probably code that you have already. If you don't have this already, I probably should have uploaded it somewhere so you could start from the same place, but we'll go slowly, so maybe you can kind of like incorporate what I've already got and kind of add in what I'm about to start changing as we go. All right, so any like questions or things that people were confused on from last week before we just jump right in and start playing with some new stuff? Everybody good-ish? All right, well, let's start doing a couple more things. This is really just quick little stuff to explore how else we could move stuff around the screen. This won't take too long. Hey. So actually, the first thing I'm going to do before I do that is save this. Let's call this, it was number 5. Let's call this number 6, just to kind of keep straight various stopping points. So the one thing I'm going to do is I'm going to import a new module this time called math. So we'll see what we're going to do with that in just a second. And let's see, what else do I want to change here? So, all right, so the next thing we're going to do is we're going to change some of the stuff about how stuff moves around the screen. So if you recall before, we were just kind of moving this face linearly on every frame for 100 like frames of video, right? I'm going to do a similar thing to start off right here, but just change the numbers up a little bit, just to make sure it looks like it's supposed to look like in the end. So if you recall, that face num variable is going to loop up from 0 through 99 for the 100 iterations of that for loop. And so what this line is going to do is, since this is our x coordinate for the picture we're drawing, we're going to start off kind of with an initial value of minus 200 when face num is 0. And then essentially we're going to be adding 4 to it every time to the x coordinate every time through the loop, right? Because it's 4 times face num minus 200. So what that's going to mean, right, it's going to move kind of from left to right 4 pixels at a time, each run through the loop. And then, so that's not too interesting, but let's add some math to this, because everything is better with math. Let's try something like this. All right. Now, can anyone hazard a guess without running this file yet to find out as to what this might do? Well, first of all, does anybody have a guess as to what math.sin is?
It's a really bad thing you can do with math.
Yes, well, there are many sins you can commit in math, dividing by 0 and what have you. But what mathematical function starts with sin?
Sign.
Yeah, good. So, all right, so math.sin is just taking the sign of something. To be honest, because I just kind of hacked this code together, I'm not even sure if that's in degrees or radians. I think it's in degrees. Maybe it's radians, though. I'm not sure. All right. But each time through, the y value of this image is going to take on a value that's like some multiple of the sine of basically like where it is in the loop, right? And multiplied and divided by some factors, but basically we're taking the sine of this increasing number that goes from 0 to 99, right? So what is that going to look like when we play this? Anybody got a guess? That's probably a good guess, since it is a sine function. Oops. And the answer is crash. The answer is crash because I didn't put the little smiley face image. And foreshadowing, we're going to get a frowny face later today, so try to just contain your excitement there. All right, so this should work. Hey! Ooh, pretty. All right, so have people tried that? Have you got that working yourselves if you're following along in your own code? Does that make sense why that's happening? Everybody, like the numbers exactly don't make a whole lot of difference. But actually, let's, just to like make it clear, maybe let's look at some stuff in just the Python terminal. So like, if you want to see what's really going on there, first we got to import our math into our little shell here that we're using. And we can do like, math.sine 0. Oh, so this is in radians. Now we know. Dot sine, if we do like 3.14. Wait a second. Didn't I just say this is in? Oh, wait, yeah. Sine of pi is also close to 0. Right. So math.sine of 3.14 divided by 2 should be about 1, right? Everybody remember your sine function? So, like, it doesn't really matter if you don't. But yeah, sine of like half of pi is 1, sine of pi is 0, kind of goes in a circle around the axis. This doesn't matter too much if you're having like traumatic flashbacks to trig. Don't worry. The whole point is that if you count up, so let's say like for x in range, let's just say 10, print, oops, somehow I hit caps lock, print math.sine of x. All right, so that's going to print us like the sine of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever, right? So there's a bunch of numbers that form a sine wave. But of course, if we want like a nice, steady, smooth sine wave, you see that like, what is it? The sine function runs from like 0 to pi and then back to 2 pi and repeats every 2 pi, right? So like your whole sine function is covered in the range 1 or 0 through 6, basically, right? So like if you wanted more fine-grained numbers in your sine wave function, you might do something like let's do like range 30. Let's do range 50. And print math.sine x over 10.0. You came in just in the funnest part, the sine wave portion.
Oh, good.
Yeah. So let's see what's going on here. So we're looping. So x is the numbers 0 through 49, really, right? Because that's how the for loop works. And each time through the for loop, we are dividing that by 10 and then taking the sign of that, right? So what you're getting in the output is like this number that goes up to about 1, then cycles back down to 0, then goes down to about -1, and it looks like we get 50 divided by 10 is 5, so that's about 3/4 of the way around the circle, right? That's a little bit less than 2 pi. So anyway, the numbers are not important. The point is, like, everybody see how you can like factor in math calculations into like your coordinates. Now, one other thing, I'm not sure if Josh went over this. Anybody know the reason I put x divided by 10.0 as opposed to x divided by 10?
Something about a float nonsense.
Yes, that is correct. So this is a weird thing about Python. Actually, I think I accidentally copied and pasted that. Just like, stop, go away, cancel. All right, good. So yeah, like one thing to keep in mind is that Python has different ways of representing integer values versus what we might call floating point values, or just you can think of them as decimal values. So if I do like 1 divided by 2 in Python, you might think the answer is 0.5, but it's actually 0, right? Or if you do like 5 divided by 3, the real answer is like 1 2/3, but Python just says 1. And that's because this is integer division where like there is no decimal stuff left over, right? So it just gives you, or if I do like 9 divided by 4, it just gives you 2 instead of 2.25 or whatever. So that's because Python represents straight up integers differently from floating point numbers. So instead, if you did like 9.0 divided by 4, you get 2.25, right? So the reason why we had that 10.0 up here in the code is because if it was just straight up 10, basically Python, if it sees a decimal in the number anywhere, it knows to interpret it as a floating point number. And then any other math you do with that floating point number is also done as a floating point number. So if you try to like divide or multiply or add or whatever an integer with a floating point number, it defaults to like keeping everything in sort of floating point terms. But if you keep everything in integer terms, it does everything as integers. And then you're going to have a bad time if you do it in your loop like this. Anybody have a sense of what this is going to do if I do my loop like this with 10 instead of 10.0? Yeah, it's going to look, well, let's see. Yeah, it's going to look all jerky because it's rounding each of those numbers before it takes the sign to the nearest integer, basically. Or not rounding, really, but like truncating the decimal portion. And that's not what we want. We want the like actual exact value, so we have to keep it in floating point. Okay, this is probably the mathy stuff you don't have to worry about too much right now. The only reason I really wanted to do this was just to show you that you can get some like relatively cool complex behaviors out of just a little bit of math added to your for loops. So just to like make one other small addition to this, right now we just have in x, we just have it going left to right, right? But instead, if we also add in a little bit of math to the y, or the x coordinate, sorry. So we just do the same thing, but with the cosine function instead of the sine function. So before what we had is just going left to right with a little sine wave, drawing out a sine wave. If we add, what do we think COS is? Hopefully you can guess in context. Cosine, excellent. So if we add a cosine for the x coordinate, what is that going to make the animation look like? Anybody got a guess? So if your y is still going like this with the loop, your x is going to be doing kind of the same thing, but in this direction. What happens when you do a sine wave and a cosine wave at the same time? Ah! If it never made sense to you why like sines and cosines were like always expressed in terms of circles, maybe that makes it make a little more sense, right? If you're doing like a sine wave like that in the x direction while simultaneously doing a cosine wave like that in the y direction, it looks like a circle, right? So anyway, this is not to like make you guys your eyes bug out with trig, but the point is, you know, if you're doing like vision, psychophysics, oftentimes you're doing stuff at like different eccentricities. Sometimes you want to calculate like distances and stuff. So, you know, sometimes there does get to be some math in your programming if you want to like figure out where to put stuff on screen. So that's just to kind of show you that you can do some relatively sophisticated stuff. And again, we're still in just like 12 lines of code, right? We just added a little bit of trig to calculations. Okay, so does that basically, I don't want to like dwell on the mathy parts because that's not fun, but does that kind of basically make sense, the kind of stuff you can do just by making the math a little bit more sophisticated when you calculate your pixels? Is that everybody cool on board? All right. So let's forget about math for a while. That was just to finish up kind of what I had planned for last week. Let's jump into like the cooler, newer stuff for this week.
I have a question.
Yes?
Where in there does it point to the picture smiley face?
Oh, yeah. So that is right up here. So basically we define the file name that we're going to be loading in here. And then this line is where we actually use that variable. So when we create so this is some of the stuff you missed last week. But basically, like when we import psychopy.visual, that's like a bunch of PsychoPy's functions for dealing with visual stimuli. In particular, we're creating what it calls an image stim, which you might guess is a representation of a picture. When we create that, we give it what window we want it associated with, which is that window we create up here.
Okay.
We give it the name of an image file to load in and an initial position.
Okay.
And then we can draw it later on, yeah.
Is image file a place, or you just called it?
Oh, so image file is, I mean, like, we create a variable here, you know, with the text smileyface.png in it. And that's the name of the file.
Does it need to be in a certain place for the computer to find it?
Well, by default, like this, it's in the same directory as your script is in. So you could give it like the whole path of your hard drive, like, you know, if you're on Windows C:\\, you know, users, you know, on the Mac, /volume /Macintosh HD / whatever. But usually it's easier to just make it relative to like your current folder. And if we had it in like a subfolder, if I had it in like a stimuli subfolder within the same folder as my script, you could do something like stimuli /smileyface. You know, if it was in a little stimuli subfolder. So you can use either relative file names or absolute file names, but yeah. Okay, and actually we'll be doing a little bit more with this shortly, so if that doesn't quite make sense, we'll kind of get a little refresher as we talk about what we're going to add to this next. Okay, so let's start thinking about, actually take some of this math and everything out of this, but let's go a few steps towards making something that kind of might look sort of like an IAT task. So first thing we're going to do, actually, let's take out that math because everyone hates math and likes randomness. So let's actually just replace this. Instead of determining what's going to happen in this next iteration of the script with sines and cosines, let's just do some random stuff. And I'm going to make a couple other little variables here. I'm going to define just a couple of set x coordinates. I'm going to call one left x, set that to -200, and right x equal 200. Okay, so those are just numbers. Those are just basically giving names to those numbers, right? Just to make our lives easier when referring to them. And again, as we talked about before, like, not to foreshadow too much, but these are going to refer to like pixel coordinates on the screen, right? And if you recall, 0, 0 is the very center of the screen. So left x and right x refer to like 200 pixels left of center and 200 pixels right of center in the x direction, right? So we're going to be using those to display our stimuli in various places. The other thing I'm going to do, actually, or one of the other things I'm going to do, is take this thing here where we create an image file, or not an image file, rather, an image object. I'm going to move it up here just like this. And let's just do a couple things with this. So let's take this actually out of it. So now all we're doing when we create our image is just giving it the window that it's going to be drawn into and the name of the image file, right? We're not giving it anything about position when we create it. And actually, let's just take this stuff out for the moment. We're going to be adding more in a second, but we'll just take that out for now. So if I just leave the code exactly like this, what are we going to draw when I run this? So at the top of the code, we just define some values ahead of time. We create a window and we create an image stimulus. Then we loop 100 times and draw, flip, wait. And then at the end, we wait for our key press. So what is this going to actually look like when we do it?
Smiley face every 20 or 2 seconds.
Right.
We'll just be in the center though, so we haven't done anything with left or right eye.
Exactly. Yeah. So right. So I haven't done anything to give it a position. By default, when you create an image stimulus, its position is just the center of the screen. So it's technically it's drawing it 100 times right now, but we can't tell because it's just drawing it in the same exact place every time. Right. So everybody cool with that so far? That idea. So it draws it 100 times, waits for a key press, and we're done. Okay. So now let's make it not just do that. Let's try something like this. So I think you guys did a little bit of did a little bit of if-then statements with Josh, right? So this should hopefully be a refresher. If you don't recall this, that's cool too. And actually, one thing I'm going to do is actually let's take our loop down from 100 iterations to just 10 because we don't need that many. And then we're going to say this. Well, actually, we're going to be using our random functions, but let's actually like explore what our random functions do before I use one. So let's import random into our little playground we have in the shell. We're actually going to be using a function called random.random. And that sounds a little redundant, but basically, remember that the first random before the period is the name of like the general like module or set of functions we're importing that we're asking to use. The second random is the name of the specific randomness function that we're using. And as it so happens, the basic randomness function is just called random. So it's random.random. There are plenty of other functions related to randomness in that random module, but we're just going to use this basic one for now because this is very similar to the kind of random number function you would have in other programming languages. So rather than use any of the more sophisticated ones, we're just going to use this one because these ideas will translate relatively well to other languages. So it's perhaps given away by the name, but what's happening every time we call random.random based on that?
It's probably a random number between 0 and 1.
Yep, random number between 0 and 1. It may not be obvious from just this many samples, but it's going to be with a uniform distribution, meaning that like every number between 0 and 1 is equally likely, right? As opposed to say like normally distributed random numbers, which you might often want if you're doing like psychology type stuff or stat simulations or something. But yeah, here we're just getting like a bunch of random numbers between 0 and 1 every time we do that. So that's useful, right? Because even though it's only within the range 0 to 1, we can do stuff with that to like make any kinds of decisions based on our random number that we get. So let's say, for example, I want to basically do a coin flip. I want to half the time randomly present the smiley face image on the left side of the screen. Half the time randomly I want to put it on the right side of the screen. Okay, so I can do that with an if-then kind of structure based on a random value. So if I want to write a line of code that says like if, basically I want to use random.random to make a kind of coin flip, 50-50 kind of decision, what do I have to do? Like what's one way I could use random.random to make a coin flip out of those like 0 to 1 random numbers?
You divide by 2 and it's like 5 even.
Well, yeah, I mean, you're in the right ballpark, but it's a real valued number between 0 and 1, or you know what I mean? It's like a decimal number between 0 and 1. So what's the like actual mathematical comparison I need to make?
If it's less than 0.5, it's 10.
Okay, exactly, yeah. So if I say just pick a random number between 0 and 1, I just cut it right at 0.5 and say, so let's say, yeah, if it's like less than 0.5, we'll do one thing. Actually, I'm going to leave that thing blank. And then otherwise, do the other thing, right? So it's going to look something like that. And again, remember if you have forgotten already, I don't know how much detail Josh got into, but the if statements in Python have to end with a colon, as do the else's. And then remember that the stuff that you do has to be indented relative to the if and else to like tell it what chunk of code to do. And again, if you have done zero programming before, this may still be confusing to you. Again, please feel free to ask questions. If you've done a bunch of programming in other languages, you're probably used to if-else statements by now, but if not, always feel free to slow me down. Okay, so let's do this. Let's say half the time we'll do this thing right here.
No, someone's at the door.
Oh, yep. I have an uncanny ability to start closing the door like right before the last person shows up. Well, we'll see if you're the last person. All right, so let's type this out and then we'll talk a little bit about what it actually means. Although, again, maybe by context, it's semi-obvious. All right, so if we do that, what is going to happen there? so we already established that we're kind of taking a 50-50 shot. So what's going to happen half the time?
It's gonna be on the left side of the screen, the right side of the screen.
That looks like it, right? Yep. So, oh, and you know what? Let's do this also. Let's add a couple of other, well, we can do this and then we'll see why I realized we need to add in a couple more lines of code. All right, so that was very quick. That ran like a little too fast to even tell. But it did look like it was, yeah, it drew in a bunch of places left and right. So let's add a little bit more like delay and see if we can see that a little bit more clearly. So let's actually change this psychopy.core.wait to like say half a second. So we wait half a second in between drawings of the smiley face. Okay, that looks like it's sort of randomly going left and right. It's still not super clear because like what's happening every time it's in the same place twice in a row though, it just like looks like it doesn't move, right? So maybe a better thing to do would be to add a blank screen in for a brief bit before we go on to the next thing. So does anybody have a guess as to what we could do to just draw a blank screen in between smiley faces?
Do like my flip, something way back at it.
Yeah, so, right. If you remember what we talked about with the flip thing, what that means, right, is that you have this canvas, you draw a bunch of stuff onto it, and then it, it doesn't show up on the screen until you actually like flip it around, right? And when you flip it around, the reverse side of the canvas gets blanked out so that you can start to draw new stuff onto it. But yeah, if you call mywin.flip, without having drawn any stuff into the window since the last flip, let's see what that does. And let's add a little wait there too, so it waits for a little while. Oh, psycho.
You still have to have that first slide one flip in there. Or is that
That's intentional, yeah. So let's run it and see what this does and see if that makes sense. We'll like step through this with a little more care in just a second. All right, so that should be like half a second on, about 0.3 of a second off for each of those stimuli. Does that look about right to you guys? So so let's look through that a little more closely. Is that clear why that's the case? So like basically each time we go through our for loop, we're doing all this stuff, right? On each iteration. So 10 times we're doing all these things. The first thing of which is we get a random number and check to see if it's less than 0.5. If it is, the image is going to go on the left, and we'll talk a little bit more about how that's doing that right there in a second. If the random number wasn't less than 0.5, we put it on the right. Either way, then, what we do next is first draw the image onto the backside of the invisible canvas, and then flip it around, so that's the thing that people actually see on the screen. Then wait half a second, so that's the half a second that the picture is actually on screen and visible, right? Meanwhile, we've got a blank, reverse side of that canvas, right? So when the next thing we do is flip, we're showing a blank canvas to the world, waiting another 0.3 seconds. So we just stay on that blank screen for 0.3 seconds and then do it all again. So does that kind of basically make sense to folks what that's doing? Is everybody kind of on board with that idea?
A little bit off on why, so still off on why we need the first flip.
Okay, yeah. Well, let's see. So if we comment that out, and this is like, it's good to go over this because like, the whole like two canvas flip thing is very common. Like Psych Toolbox does this too, and like, I mean, this is kind of how the computer works. So anything that doesn't obfuscate how the computer works is going to work like this. But it's super confusing. I remember from teaching this before, so like it's good that we go over this. So we eliminated our blanks by doing that. And why is that? Does it sort of make sense now why that first flip is there?
So you're flipping twice, essentially. The one flip kind of makes it the blank screen, the other closes
Yeah, so maybe another way to make this more intuitive would be to like add a little comment here and pretend that we're like draw a blank screen or something like that. So what we're really doing, right, is two things on each loop through, which is we draw the actual picture to, again, not to the, when we say draw, it's a bit of a misnomer, right, because you're not actually putting it on the screen until you flip, right? So draw just means like, you know, think of yourself as the painter, like I'm drawing it on my side that I can see, but then until I like flip it around and show it to you, like you, the subject, don't see anything, right? So I'm like draw, 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 and then I flip around my beautiful painting of the smiley face with this line, and you know, magically as I do that, the canvas, the side of the canvas facing me goes blank again because it's a magic canvas. I wait half a second. Here, I mean, this is just a comment, right? But basically, like, I haven't done anything to make the canvas facing me not blank, right? So it's still blank. So then what I do is, after that half second wait, I flip the canvas around again, show you the blank side, and wait on that for 0.3 seconds before I draw anything else, right? Is everybody cool with that? So in other words, if we like take out that first flip, you know, again, you can just think of this like a real person doing this. Like, so I draw the smiley face on my side of the canvas. I just sit here and admire it for half a second, right? Because I haven't actually shown it to anyone, right? So you draw it, keep it on your side of the canvas, wait for half a second. Don't do any, well, so here, like, the comment doesn't make any more sense, right? Because, like, you're just not doing anything, right? And then I flip it after just staring at it for half a second. And then I wait another 0.3 of a second, right? So at no point, and so then the next time through the loop, you know, I'm looking at a blank canvas and I do the same thing. Like I draw it, just sit there and stare at it for a while, then show it to you. You know, so there's no point at which I draw nothing and then show it to you. Does that kind of make sense to everyone? I know this flip stuff like drives everyone nuts until you like really kind of get it inside your head. But
I mean, I think it makes sense if you just think about the fact that most programs that measure latency are doing this, right?
Mhm.
So that you can get accurate response time to that.
Yeah.
Just that you normally don't see that it's doing that.
yeah, I mean, right, like, yeah, you just don't, like I said, this is kind of how the video card of your computer actually works. I mean, if you think of it like, and the reason it's done this way is because, like, you know, in the old school days, like we had CRT TVs, right, that like drew every line of the display. For you that are young, TVs used to be very large and heavy and made of glass. What's that? Yeah, exactly. And they had like electron beams that like shot electrons at a screen. You know, and it would like draw a line, draw a line, draw a line, draw a line, right? So like, if you started changing what the signal was that was going to the TV, like halfway through, if anybody who is old like me played like the old school Nintendo when like too many like guys got on the screen when you were playing Mario, you would start to see things like flicker on and off because it was like trying to change stuff, but it couldn't keep them all in memory at the same time. And so you get things like if you start to put something on screen when the electron gun is like halfway through drawing the screen, you get like half of a thing drawn for one frame before it like starts over and draws again, right? So the thing that you're really supposed to do is get your screen all set up, get your video signal right, and then change it right when that screen starts getting redrawn, right? Which is why we do the split thing, basically, right? Which is you don't want to draw like you don't want to have your image changing halfway through a screen draw. So you do this flip thing, which basically like it's literally doing is like the video card saying like, all right, I've got like two kind of representations of the screen to like switch between. So as soon as I'm ready to like draw a totally different frame, I just switch rather than like changing the memory on the fly, and like then you get this weird thing where it looks like stuff that like half of something is showing up for one frame. Anyway, more engineering than you probably need right now. But does that make sense now, the way that we're doing it this way? Everybody cool so far? All right. Now the one other thing, like before we move on from this, is let's talk a little bit about what's going on here, because we haven't talked a whole lot about like objects. We've talked about like making objects and kind of waved our hands. We haven't talked a whole lot about like what objects are and how they do stuff, right? So anybody got a sense of what's really going on here when we set myimage.pos, you know, randomly either to be like the left coordinate or the right coordinate? Anybody got a sense of what that means and why that?
An X and a Y, right?
So we're giving it an X and a Y. How does that translate into where the image shows up? I don't know if that makes sense to ask that question for you guys, but. Well, yeah, it's got coordinates. So I guess what I was trying to drive at is, if you remember, when we created the image, what we used to do is specify the position of the image when we created it, right? And that was fine. And we were just like creating a new image every time we drew it, right? Or a new like variable representing that image every time we drew it. But we don't really need to do that, right? So this, this variable named myImage is what we call an object, right? Meaning that it is a variable that has both information in it of different kinds and stuff it can do, both with itself and with other objects, right? So what we're really doing is we're telling it like what window to associate itself with when we create it. And in this case, like what image file to load in, right? And we used to tell it what position it had, but now we don't tell it that when we're creating it. And again, don't worry about the exact like syntax here, whether it's commas or equal signs or whatever. Don't worry about exactly how we say that. But we leave up what its position is. We leave that to like down here, right? So yeah, like left x and 0 define a coordinate, and right x and 0 define a coordinate. But what we're essentially doing is, we know, because we have looked at the documentation for PsychoPy, that each image object, one of the things it has in its like bank of information is a little subvariable called pos, or you would call it in sort of programming parlance a property. So pos is basically like a 2-item list of numbers or a coordinate indicating where the image is, right? So every image has a position, but we haven't set it until we actually like kind of do it right here. So let me just do this to like make this a little bit clearer here. So if we put something like that in, what's that going to print out to the text output when I run this? Does anybody have a sense of that?
It's whether it was on the right hand side or left hand side, like the negative 200, 200, and then it's going to be 0, the other corner.
Okay, that is generally correct. But as the sort of trick aspect of this question, what's the very first thing going to be that this prints? Because it's going to print 10 times, right? Because it's a loop. What is the first thing that's going to get printed? Anybody got a guess?
It'd just be 0, 0. It's start like this.
I would call that a solid guess. Let's see. All right, so just going to do the thing, and then we'll see what it printed out to the output. Okay. Let's see. So it printed a bunch of x and y coordinates, but the first thing it printed was 0, 0. Good. So this is just to say that, yeah, like when we first create my image, every image object has a position, but it's, if you don't give it a position when you create it, it defaults to 0, 0. If you guys remember when we did that first little demo, it just stayed in the center of the screen. And so it starts out at 0, 0, but then before we ever draw it, we do change it, right? So the fact that I printed it before we changed it is what means that it prints off 0, 0 the first time, right? So like, in other words, if I were to move this line down below to like here, it would never print 0, 0 then, right? Because it's already been changed to the first left or right coordinate by the time we print it. Does that kind of make sense to people? Sort of? Okay. And again, if you haven't done a lot of object-oriented programming before, this may be a little confusing, but let's PsychoPy visual. So the key thing to know is that, the only reason that we know that we have that image objects have this. Oh, you know what? It would help if the Wi-Fi were on. The only reason we know that image objects have this position attribute is by looking at the documentation, right? By looking at who originally wrote the code for the image stem object. Let's see if this actually works. Oh, there we go. So this documentation is going to be still pretty, if you're not familiar with Python and PsychoPy, this documentation is going to be pretty like unintuitive to you. But the key thing is this is listing like all the stuff that image objects know about themselves and keep track of, all the information they keep track of, and also all the stuff that they can do. So when we create one, there's all this stuff that we could specify, or we could wait and specify it later like we did with that position attribute. So if we scroll way down, somewhere in here should be, like position, right? So this is giving us an example of a few different ways we could set your stimulus position. But you can do other things, like you could have opacity. So, you know, if we wanted every time that it's on the left, my image.opacity to be like 25%, and every time it's on the right, I didn't actually do this in my test code, so hopefully this works and doesn't bug out for some reason. In theory, that should show us different levels of opacity depending on which side it's on, right? Does that make sense to people? So, like, the only way we know like what attributes we can change about that image and what they're named is by looking at the documentation. That's not something that you're just magically expected to know, in other words, right? I'm not sure if I'm making this clear. Do people have a sense of how objects work and how we change their values and so on? So like basically you can think of pause as like a little variable that every image stimulus has, and you can change it. And then what happens is when it comes time for when you tell the image to draw itself, it looks at all of its attributes and says, all right, I'm in this position right now, I'm at this opacity, so when I draw myself, I will take into account all of these things that you have set up. Is that sort of clear? Does this like that dot notation make sense? It's not like freaking everybody out? Okay.
So if you were to like type in the opacity line before the if-then statement, it would make both of them.
Yeah, if we were just put it like up here, you know, I could say like my image dot opacity. Oh, I was gonna try to be cool and tab complete that, but I missed it. Oh well. So like if I want to just set it to like 0.05, I could just set it right there. Now that's just going to do that every time through the loop. So like it's basically going to have the effect of like always setting the opacity to 0.05. Like, you know, you're technically calling that line every time it runs, but it's not changing anything, right? Yeah, so you can do all kinds of stuff like that. I guess the key point to note is that like, and this is something that kind of confuses people sometimes, is that we use this dot notation basically to refer to like both properties that the object has or variables or information that it tracks. So like the one named opacity, that's just a number. But we also use the same notation to refer to things that the object can do. It's just that we use those parentheses to indicate that it's a function and not a value that it tracks. Is everyone still kind of on board with this? Like this is stuff that I know people tend to get confused when they first start, and we're not like, to avoid going into the deep dive, we're not going too far into like what an object is. But people feel good about this?
The dot and the pause is some sort of attribute of the object, and the dot with a word, and then these
and
two
then parentheses.
function.
Yep. Yeah. So basically, just think of like without parentheses, it's just a variable, but it's a variable that's kind of like a sub variable of that object. With the parentheses, it's a function that object can perform. Yeah. Okay. All right, so let's save it in this state, and let's do maybe like one or two other quick little demos, because I think it's like 2:45. So everybody still cool with this? I think we can get through two more demos, and you will maybe be surprised at like how functional of a task we have at the end of this. Maybe. I don't know. I don't know how easily surprised you are. So for this next thing, if you're following along, you're going to need one other picture, which is here, if you need to download it. MatthewRJohnson.net/shared/frownyface.png. If you didn't have the smiley face image, it's at the same address, but smileyface.png, SMILEYFACE. So we're going to drastically increase the number of things this task can do by putting two different images in that it can draw. And let's just do that like this. So I'm going to save this as a new file again, call it demo9. And let's see what we're going to change. So one thing I'm going to change is I'm going to change this variable because now we're going to have two image files. So I'll call the name of the smiley face file image1. And let's call this one like image2 file. And let me actually make sure that I've got, nope, I don't have my frowny face in the folder yet, so let's copy that into the same folder as my code. Okay, so now I have like the names of two different files here. Leave that stuff the same. Leave the window creating line the same. But let's actually, now we're going to have two different images that we might draw at different points. So let's call the first one the smiley face like image1. And let's make another representation of an image file. Oh, yep. Thank you. Yep. So I got rid of the variable just named image file. So, yep. So the first image1 is going to get initialized with image1 file, which of course refers to smileyface.png, and this one is going to get image2 file. So everyone clear on what that's going to do? That's going to create two like representations of those two image files, both associated with the window that we have just created. And let's do this. And this may make the image property or the image attribute stuff. I'll use those terms probably relatively interchangeably, but that'll make that stuff a little bit clearer. So let's just get rid of the first part of those lines and just change it to pause. So that's one thing we're going to do. And so essentially what that's doing is just creating a variable named pause, right, that has that coordinate. And now let's actually add another whole like little chunk of code. And let's get a different random number. Whoops, random. And again, do kind of the coin flip thing. This is just a personal quirk, but I always like to like put the structure of my if-then statements in before I actually put the code in, just to like keep the structure of the program in my head. Because sometimes you get all excited about your if and then you forget to write your else. Depending on how exciting your if is. All right. So I'm just going to do this, or write this out, and then you guys can tell me what it's going to do. Again, don't run it yet and spoil the fun. Image2 dot pause equals pause. All right. I think that's all the stuff I need to do to make this do what it's gonna. So if you can follow the logic of this, what's going to happen here?
It's going to randomize both the position and which image is shown.
That looks correct to me. So let's see if we are right. Oops. Oh, just kidding. All right, so let's find out who. Oh, all right. So who sees what I did wrong here? That is correct. Right, because we already drew the appropriate image. We got rid of the variable named my image, so I forgot to take out that. Oh, yeah, good call. Yeah, that wasn't even in that was just a little random thing I added, so I didn't see to take that out. Yep, all right, so let's try that. The best part of doing these things is the live debugging. All right, well, it looks like that is randomly drawing either a smiley or a frowny face, either on the left or right side of the screen, right? Everybody see kind of how that works? So just to like step through that a little bit, right? So what we're doing is each time through the loop, we're doing this 10 times, get a random number, see if it's less than 0.5. If it is, we make a variable called pause and make it basically that left xy coordinate, minus 200, 0. Otherwise, the other side of the coin flip, pause represents the right coordinate, 200, 0. And again, like right now, that variable is just like a number, like a pair of numbers, right? It hasn't been told to do anything yet, right? It's just literally saying like, all right, now this name pause, refers to either this coordinate or this coordinate, then we get a different random number, right? So every time we call random.random, we get a different random number. Check if that one is less than 0.5. So again, this is just another kind of coin flip situation. And on one side of the coin flip, we set the position attribute of the image1 variable, right, which is the object representing the smiley face. Set that to the position that we just assigned up here, and then tell that image to draw itself, right? And then otherwise, on the other side of that coin flip, we update the position of image 2 with the position we already decided on, and tell image 2 to draw itself instead, right? And then either way, regardless of what we've drawn already, we then flip the canvas around, so we show whatever we've drawn, and then do the weighting and the flipping of the blank canvas and everything else just like before. Is that clear? Does that like step through make sense to everybody? Is there any part that anybody like does not see why we did it the way we did it, or just doesn't understand the notation of the line or something? Is that still kind of making sense to people roughly? The logic of this stuff. All right, I think we've got time for one other quick demo, and just to like kind of end in a good spot, or like maybe add a little intrigue for next time. Okay, so let's do one more thing here. Let's see what else we have to add in. Not too much more. So let's define one more variable up at the top here where we're just kind of defining, again, if you weren't here when I said this before, like we could just put all these numbers in the script, but that leads to ugly code. I know the code is already full of some numbers, but you know, if we ever wanted to like change kind of the locations of stuff, it's better to like have it right up top where it's easy to change, and you just have to change everything once. So I'm going to add a variable called text_y. You might be able to guess what we're going to be doing next. And I'm going to make a couple of text variables. So this is a new type of object we haven't seen yet, but it's called a text stem. Again, you might be able to figure out what that is. Text. Let's just, oops. Let's actually just leave that there for now. And we'll add in a couple of refinements in a minute. And do another line like this. Okay. That's sort of the minimal thing. Well, let's start off with this, and then we'll see what else we have to do in order to get this looking nice. So I'm going to just add at the beginning of the loop, oops, these two lines of code. And actually, now that we've got our, well, let's just do it like this for now, and then we'll keep modifying this code. So has anybody got a guess as to what this is going to do when I run it?
Show the words smiling and frowning, both, but they'll be like overlapping.
That is very astute, I would say. Yeah, so this is not going to be good code the way it is now, but we're getting there. Yeah. All right, so we've still got our faces flipping side to side, but now we've got two text items. Unfortunately, because we didn't give them a position yet, we're just drawing them. Hey, we're just drawing them right in the center of the screen. So that's not what we want, right? But does everybody see what's going on there? And does everybody see kind of the value of, or how this flip thing is starting to work now, right? Because this is the first time we've drawn, well, actually the first time in a couple of weeks that we've drawn multiple items on the same display. Does this kind of make sense? So, you know, we're drawing all these things and then only flipping once at the end when it's all drawn, right? Okay, but yes, so we don't want to draw everything right in the center of the screen right like that. That's not what we want. So maybe we want to do something like give the text stem a position attribute as well. And if you look at the PsychoPy documentation, you can just trust me for now. You will see that it also has a position attribute that's also just a pair of numbers enclosed in brackets like this. So we'll do that for each of these. All right, so let's see what that looks like. Well, what should that look like then? Where should we get those smiley and frowny words now? Yep, smiley on the left and up a little bit, right? And then frowny on the right and a similar place.
Why is it up?
Because we also set the Y of the position. It had an X and a Y coordinate. You'll see in a second when we get back to the code.
Up from the middle. I thought you meant one.
Oh, yeah, sorry, yeah, like just up from the center of the screen, right? So that text Y we set to 200, so both of those are going to display 200 pixels north of the center of the screen. Now, if we wanted this to, like, again, if we're sort of going towards an IAT type task, really we've actually got more here than we strictly need, right? Because I think, I mean, I've run a lot of IATs, but I think typically with an IAT you just kind of present the thing you're making a judgment on centrally and then have like the choices, correspond to left and right buttons. So we could actually like just kind of take out all the stuff about the positions of the little faces. Let's get rid of all that position garbage. I think that's it. So what's this going to look like now when I run it like this? Hopefully, yeah, hopefully we'll get, just a randomly selected smiley or frowny presented in the center of the screen. With labels up at the top. So that's pretty good. And actually, the only weird thing is it's kind of like strange to have it like blink like that. So if we wanted the, well, I just cheated by telling you probably what I'm going to do next. If I wanted to have the text display all the time, even when the face is not on the screen, what might I do? What's that? It's an interesting thought. I mean, I see where you are. That makes sense in some ways. What's that? All intriguing ideas, and on the kind of right.
Wrong.
Well, on the all on the right track in sort of conceptual terms, although it's not actually going to do what you think it's going to do. So like if we take this out of the loop entirely, what that's going to do is just draw it the first time and never again, because every time it flips, it clears the screen. So that doesn't quite work. What Rafi said, there are ways to like not have it clear the screen when you flip, but the problem is then you have to like paint over your smiley face with a blank screen. So you'd still have to do some work, even if like that option, if you employ it, is nice if you're like adding stuff onto a display and compositing it, like with each flip. But if you have to like erase some of it too, it's not as helpful. So the answer. Anybody got another suggestion for where to? Like maybe right around there, perhaps? I think that's what you're saying, right?
Yeah.
So just put one there and one there. Yeah, so right, because before what we were doing is we'd flipped, we were just waiting, and then we flipped immediately again to like show a blank screen. But what we can do is instead of showing a blank screen, we can draw just the text, but not the smiley face, onto the screen again before that second flip. Okay. Does that make sense to people why that works? I guess we're a little past 3 right now, but in other words, what we're doing is each time through the loop, we'll draw our text, draw our image, our randomly selected image, flip. So we've got text and image on the screen at the point of this flip. Wait a half a second, and again, now our back canvas is blank, if you can keep that in mind. But then we draw text 1 again, draw text 2 again, and then that's all we've drawn on our private canvas. Then flip that around, so all you see is the text. Flip that around, and that's all that you see for 0.3 seconds. So you've got the impression of static text labels on the screen with this changing image every 0.8 seconds or so. The only last thing I'll do, just to actually really just mainly for my own sake, is to get this into the shape of the last bit of demo code I wrote. Note that you can also change other attributes about the text. So if we wanted to like really make it look a little bit more like a task, you can set things like the boldness and the pixel height. Again, these are all things that are documented in the PsychoPy documentation. Like, you can't put any old word there. It has to be something that is like defined as a named attribute of these text stimuli. So now we've got like something that looks a little bit more like a task, right? So this is starting to look kind of like a task, right? If you replace, we'll keep it, inoffensive and keep smiley and frowny rather than like worrying about what races and good or bad attributes to pick for an IAT type task. But you can see this is kind of the basic structure starting to come into shape, right? Now we're not collecting any responses yet. We probably don't have the timing quite right. There's probably many other things we could do, like give some constraints to the randomness of the selection, so that make sure you have an exactly identical number of smileys and frownies, and then you're going to want to have multiple blocks where people like do different permutations of left and right, and so on. But this basic element, of an IAT type display, still only like 33 lines of code, right? And again, a good like 8 or so of those are just blank spacer lines. So not too shabby, I would say. Okay. So I don't know if are people still kind of roughly making sense to you what we did here today? Yeah. Any major questions or concerns before we kill the screen recording and call it a day? We can still chat more, but anything you want to have burning questions about for posterity? All right. Well, let's cut it there.